everyone. Today we will discuss about the topics such as finite automata and then how the tokens are to be recognized with the help of regular expressions languages together. So, first initially, we know that the compiler contains several phases, that is total 6 phases. First phase is a lexical analyzer phase, second phase is syntax analyzer, uh, third phase is semantic analyzer, fourth phase intermediate code generation, fifth phase code optimization, and sixth phase code generation phases. So out of all the phases, the first phase, which is consists of lexical analyzer phase. The task of lexical analyzer phase is accepting the source program, which is written in some C language, C++, or Java language, Python, some language to be written, etc. To be written in any one of the programmatic specific languages, and this language to be converted English language. Generally, it is written in English language like statements to be converted into machine understandable language, so that the machine can understand the corresponding language statements and then produce the output. What is the input that is given by the user? Corresponding output is to be produced. So while accepting this source program that is recognized by the lexical analyzer, immediately it divides each source of the program, which contains several sequence of instruction. Each instruction contains some characters. So words that is to be read, scanning, that is also called scanning, and then after reading character by character, releases tokens. So here the task of lexical analyzer is accepting the source program which is given, that is called as input, and delivers output as tokens. Delivers output as tokens. So this is the process that is done by this lexical analyzer. Here, after generating tokens, some of the tokens may be identifier, value identifier, and some of them may be operator, some of the constant may be a keyword. For example, if you take A equal to B plus 60. So here in this statement, if you consider A is an identifier, B is an identifier, and the plus is an operator, whereas 60 is constant. These two are operators. Equal to, plus are operators. This is not operator, this is an identifier, A and B. These two are plus, this 60 constant, numeral constant. So in this way, the expression or statement which is available in the source language can be recognized with the help of lexical analyzer and generate a stream of tokens. So while recognizing tokens, generally it uses a notation such as a regular expression is the notation. We are going to see that what is meant by a regular expression in case of finite automata in the next coming chapters. Here, regular expressions uses the concept of, that is the finite automata. You already know the finite automata, previous that is automata notation, that is where concept, and it is also uses regular language. Here, generally, what is meant by a language? Here, language is nothing but it contains set of strings. Language is nothing but it is a set of strings. Here, strings means alphabets. Language means set of strings, and strings means here, for example, it contains some words, that the sequence of characters that is to be considered as one string. Like that, several set of strings are to be available. So here, that string is to be formed, where it is to be formed from the alphabet only. What is alphabet? It contains some characters. So these characters is to be represented in the form of, suppose X, Y, or max, For example, we are going to define a function name max, maximum of numbers, minimum of a number. So here this is character A, like that the characters are to be formed, and this is to be considered one string. So like that another string, maybe xy is another string, maximum is another string, like that set of strings may be formed from that. So this one is to be considered as a language in this one. It is considered as one language. So the language is nothing. First, alphabets are to be recognized. That is characters, individual characters. That is also called symbol notation, and this is to be generated with the help of strings. And set of strings are to be considered in language. For example, here what is a symbol? So it is nothing but a unique object. So there may be a numerals, there may be a characters, that is 0, 1, 2, A, B, C. That is to be considered as a numeral values, or we can also specify a notation, that is a set of symbols. That means here finite set of symbols 0, 1, 1, 0, like that a combination of set of symbols is to be used to represent an alphabet. So I will told a characters MAX, which is to be formed from the symbols only. So this 0, 1 comes under this symbol only. Like that that is to be represented. Generally, in case of fundamental notation, we are going to represent this one as sigma notation. Sigma or tau, that is the symbol to be denoted. It is denoted as alphabet is denoted by symbol sigma. Alphabet is denoted by a symbol sigma. So, for example, here alphabet, binary alphabet. Binary alphabet, we know that binary means 0, 1. So, what are the strings that is to be generated from this alphabet? From this alphabet means binary. By this is called as binary alphabet. So, from this, what are the strings to be generated? So, either 0 or 1, or that is one set of notation. Whereas if you consider alphabet, for example, a, small b, like that Z, then you can take that consider as another alphabet, that is also sigma equal to a comma b comma, like that. Set of strings formed from that particular alphabet. Set of strings formed from the symbols, and generally it does not specify other symbols. So it may contains, keyboard generally contains various special characters. That is not allowed in this one. So only the alphabet notation, except only particular as a symbol notation, is a binary alphabet which accepting zeros and ones, or the English alphabet generally which notation represent in English letters such as lowercase letters. So only we know that a term string, definition of a string. Here we are going to define it is a combination of several characters. That means character means that is symbols which are formed from where, that is suppose we are defining an alphabet. Let's say suppose sigma is defined, then we are going to use these letters, these symbols, and that is to be arranged in one format. That notation arranging of the character symbols is to be available in a string notation. So generally, what are the symbols which are used inside this one means these are the letters to be used to denote the strings, and we are going to append that is string, two strings. Suppose for example, if two strings are available, we are going to merge the two strings with the help of this. That is called as, for example, X is one symbol which is available, Y is another symbol is available. So we want to concatenate the symbols. So this is the symbol 1 and this is symbol 2, and we are going to concatenation of symbols. XY is the concatenation of the symbols. So symbol may be, that is here in this case symbol is a individual letter, that is 0, 1, a small a, XYZ something. So while performing this operation, parenthesis should not be used, or comma is not allowed. That means if at all if you write x comma y, this is not comes under concatenation. And suppose bracket xy, This is also not comes under concatenation. That means these notations, writing comma and parenthesis is not allowed. For example, here we described a string with a alphabet. So, for example, 0, 1. For example, 0, comma 1 is an alphabet. Let sigma is defined with some alphabet 0, comma 1. Then all the strings which are defined with the particular alphabet that is 0 and 1. For example, 0, 0, 0, 4 zeros, 3 zeros, 0, 1 0, 2 0, 3 0, 4 zeros. Like that, all zeros to be considered here. That is a alphabet. That is comes under the binary alphabet 0, comma 1. So it is one string. 0, 0 is one string. This is another string. This is another string. 0 is another string. Like that, several number of strings formed from which the given alphabet. What is alphabet? 0, 1. So here 0, this example 1 0 0 1, 1 0 is also a string. 1 0 is also a string. So all these strings are to be derived from sigma. Here, for example, if you change the alphabet, for example, alphabet is changed A, comma B, then what are the strings that is to be derived from this alphabet? So it is a string which is derived from the given set. What is the given symbols? A, comma B. So the AB, ABA. So these are all the different strings which are formed um, from this given alphabet. So alphabet is to be represented with the help of the symbols, and based on the symbols we are going to define a string. So string is nothing but a sequence of symbols, that is concatenated symbols. So concatenated means combining of the individual symbols. So if you take an example x, y, then a, comma b. So this a is one symbol, b is one symbol. The concatenation of two symbols is ab. So this is one string. This is considered as string. So this string may be formed, that is to be formed from the given alphabet. If it is AB, so you can form AAB, ABA, like that different strings are formed. Suppose if it is alphabet is sigma is 0, comma 1, then the strings are to be delivered 0, 1, 0, 0, 0, 1, 1, double 0. Like that the strings are to be. Suppose for example, if the alphabet is not does not contain any of the character. That means previously we know that sigma equal to 0, 1 something, sigma equal to a, comma b something. Sometimes it does not contain any symbols, empty. So in that case, what it is defined it as, it is called as epsilon. It is called as epsilon or lambda. That means here it is called as null string. Null string. That means there will be no strings. There will be no strings in the given alphabet. In the given alphabet, there will be no strings in the given alphabet. That means alphabet is empty. Previously, I take an example. Alphabet is a, comma b. Alphabet is 0, comma 1. But in this alphabet, sigma here null string. That means there are no strings, no symbols. Here in this case, sigma equal to empty. Sigma equal to empty. So this empty is denoted by epsilon. That means there is no. Epsilon is to be indicates that alphabet sigma alphabet is does not contain any symbols. That is one of the aspect of this notation, that is alphabets and string notations. For example, we want to calculate the length of the string. We know that the characters or symbols which are available, that is a sequence of characters, concatenation of symbols is nothing but a string. For example, the string, generally the string is to be denoted by W. Generally the notation, the letter that is to be denoted by, that is symbol that is to be denoted here in the string automata, automata, finite automata, that is to be represented as W. So W is considered as a string notation to represent a string. So how the alphabet sigma is used to represent this alphabet sigma. Similarly, for a string also we are going to use a notation a different notation that is called as W. So, for example, if the string contains some XY, W, so XY, so generally we want to find out the length of the string. We want to find out length of the string. Then, how many symbols are there in the given string? So, length of the string is to be denoted by absolute mod of x, comma x and y. So, mod of xy, here it indicates the number of symbols which is to be available in this string. For example, here x is one symbol and y is another symbol. So, total 2 symbols. So, we can say that length of the string is 2. Here in this given example also, 0, 0, 1, 0. So 0 is 1, another 0, 1, 0, 0. So this is one symbol, this is second symbol, third symbol, fourth symbol, fifth symbol. So length of the string is 5. Length of the string is 5. Similarly, for example, in this case, A is one symbol, A is second symbol, B is third symbol. So length of the string is 0. Length of the string is 3. Whereas if you consider here how epsilon is denoted here, epsilon indicates that null string. Epsilon indicates that null string. Here null string means string length is 0. String length is 0. So automatically length of the string is 0. So here while calculating the length of the string, how many number of symbols are available in the string? How many number of symbols are available in the string? So XY, if you consider XYZ, then are A, B, C, B, A, number of symbols 1, 2, 3, 4, 5. So absolute is 5. So like that, we are going to define the length of the string with the number of symbols that is to be appeared in the mod of this function. So absolute function is to be defined with the help of the string notation only. And we are going to easily find out. So in this case, only the special case is if it does not contain any symbols, then it indicates that epsilon it is. Generally, the lowercase letters are to be used to represent this beginning of the alphabet notation, that is lowercase small a, small b, small c, whereas the end of the strings generally denoted with the alphabet or alphabet is small case letters toward the end, that is u, v, x, y, z of this string. That is a notation to represent the string format. And whereas another one is language. This is also an important one for the grammar, regular grammar and expressions in case of finite automata. That is to be recognized with the help of these notations only. So string, once you identify a string, so first initially we come across symbol from that individual characters, from that a string is to be formed, and then we have used a length of the string. All the combination of these strings, the combination of individual strings, separation of all the strings are to be denoted in terms of a language notation that is called as alphabet notation, that is sigma. That is sigma with the help of the what are the symbols to be defined. If it is 0, 1, the sigma is defined 0, 1. We are going to define individual string 0, 0, 0, 1, 1, 0, 1, 1, something like that. So this element, this string, this one string, second string, third string, all the strings are to be defined, put in a one separate notation, that is 0, 0, 0, 1, 1, 0, 1, 1. This is called as language, and this is L language is to be denoted with the notation as L. L is the language that is called as formal language. So we already know formal languages, theory of computation, flat formal languages and automata theory. So in that way, the language descriptor. What is a language? What is a language means? Here, a language is nothing but a set of strings that is to be formed from the given alphabet. Given alphabet sigma. So here, what is the sigma? Sigma is to be defined. Based on the sigma, we are going to define a language. So here, the strings are to be formed with the valid number of strings or invalid numbers. So based on the alphabet sigma only. So whether the string is valid or not, or the given string is available in that one or not, can be verified based on the sigma or alphabet denoted only. For example, binary alphabet, if you consider sigma equal to 0, 1, these are the two individual symbols which are available in the given alphabet. Then you can form a string with different string, that is 0 is one valid string, 00 is another valid string, 000 is another valid string. Like that, the strings may be contain different. That means 0 starting with 0, some set of strings, starting with 1, some set of strings, 0 combination, one set of strings, 0 1 combination, 1 0. So the strings to be it is not limited. So there will be many number of the contain strings to be that is to be called as infinite language. That means the strings are not limited or not in the given, not in the range. That means it is it is indefinitely continuing. So in this case, it is called as infinite language. If suppose if some of the strings are defined only specific, then boundaries, that we can say that it is a finite language. So the language here, one is a finite language, another one is infinite. So language in the sense set of strings defined over alpha, defined over sigma. Sigma is to be defined. So in theory of computation, the language is to be defined from that based on sigma only. So here sigma that is to be get from this alphabet a comma b. Suppose if sigma equal to a comma b, then what are the strings to be listed out? Maybe a, b, b, e. That means some of the strings defined over this alphabet only. That means, for example, set of string starts with A or end with WA. So something like that, the specific requirement. Then only the limited number of strings, not all the strings are allowed. Suppose if any constraint is not available, all the strings to be appear in this case, it is called as infinite language. That means the strings are to be processed continuously and there is no limit. Whereas here there is a fixed number of set of strings to be available in this language. That's why it is called as finite language over the alphabet. So here the string, whether it belongs to the given, we can also verify whether the given string which is available in the language or not. That is to be considered as a membership problem. That means here language L which contains set of strings, so it is 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, like that some strings are to be available which are defined. The strings are defined in the particular language for alphabet sigma equal to 0, comma 1. Then we can verify whether any string is to be, the given string is there which are available or not. So for example 0, 0, is it belongs to, this string belongs to L particular language or not? Is it available? Yes, the string is available. Suppose if you consider 000, is it belongs to L? No. Why? Because the string is not available in this language. So we are going to specify, verify whether the given string is to be available in the set of particular language or not. And we are this type of notations which are generally used in the programming language notations, and this is to be verified, and it is to be useful for the development of the compilers are also regular expressions, context-free languages, and decidable problems, and formal language notations. All this to be used with the recognition of tokens and verification of the strings availability or not. All these to be verified and used for the development of the compiler notations only. That's why these regular gammas and regular languages are to be very much crucial role placing this generation of the machine language. We are going to see some of the examples which are defined over this language. So we already know that a language is nothing but so that is set of strings which are formed from the alphabet, given alphabet. So for example, if the language L, for example here the alphabet sigma 0, comma 1, it is to be defined over that one. And what are the strings to be defined in this language? So what type of strings are to be defined? So based on the constraint, what is the here, it is given as a set of strings zeros and 1 with no two consecutive ones. So what are the strings which are starts with 0 or 1 which does not have two no two consecutive ones. That means whether it is a finite or infinite. So here it is called as infinite because many strings are to be available which does not contain one side by side. So the such type of string. So epsilon is an empty string, that is null string, that is to be allowed. Why? Because it does not contain consecutive ones. There is no ones in this one. And the zero, all zero combinations are allowed. Maybe 0 0, single zero, two zeros, three zeros, like that. All zero combinations are allowed. That is an infinite. And similarly, start with one also allowed. 1 1 0, double 1 0. Here consecutive ones are not allowed. So here one one with double zero, one with triple zero, like that. This one is also allowed, and the triple one also allowed. Not 1 0 1 all zeros with, again 1 0 0 1 all with one. Similarly 1 0 0 0 0 1, like that. So there will be many number of strings that is to be formed in this one. And another one example is what is the string that is to be uh, read from both forward and backward, so that we are getting the same result. So that type of strings are called as palindromes. So whenever XY, for example, if you are going to read a string um, 0 0 0, so what is the string that is to be read is same as the what is the string first 0 0. Suppose if you read the string from back, that is also 0 0. So both strings are equivalent. Then you can say that number is a palindrome number. This number is 1. That means reading the characters from the forward side, getting the string same as reading the characters backward, and which is equivalent to the string to the previous one. So that is what that type of strings is to be available. For example, null string. Null string does not contain any of the symbols, so it may be read from the either backward or backwards. Zero is only one symbol. So here we can read one time either forward or backward. Then we are getting only 1 0 only. So we are getting the same result. One also same thing. 0 0, we are getting this 0 0. Backward also 0. 1 1 also same thing. Triple 0 we have taken just now. Triple 0. 0 1 0 same string reading. 1 0 1 reading 1 1 0 1. Backward also this one. 4 zeros, 4 ones. So all this, there will be so many number of strings that is to be available as a palindrome in the given alphabet 0, 1. Another one is set of strings consists of number of zeros followed by number of n number of zeros followed by n number of ones. So here we can keep n as a, first we will start with 0. So here also 0 if we start, then n 0 number of zeros, 0 number of ones. So it is an empty string. Another one is 1 0 and 1 1. So 1 0 1 1. So another one is 2 zeros, 2 ones, 2 zeros, 2 ones. Next you can place n is 3. 3 zeros, 3 ones. Next you can place n is 4. 4 zeros, 4 ones. And you can place n is 5. Like that, based on the n value, number of zeros, 1 times 0, 1 times 1. 2 times 0, 2 times 1. 3 times 0, 3 times 1. 4 times 0, 4 times. 5 times 0, 5 times 1. Like that swan, n zeros followed by n. So it is also an infinite language where n greater than or equal to 0. So there will be many number of strings. Sometimes we have seen the example of palindrome, and we can also see the number of zeros with number of ones, and there is no consecutive ones in the first example, where each contains forms infinite number of strings over the alphabet 0, 1. So such type of languages are called as infinite languages. Infinite languages. Sometimes we are going to write a English language statement in the programming language such as C language or C++, Java programming languages, where we can observe that the language statements which are we are formed can be written in the form of alphabet notation, symbols and strings, and then some ASCII notation. That is characters. ASCII characters are to be used inside an alphabet, and then that is to be formed as string notation and word that is to be used inside that programming language. Those to be considered as a subset of the possible number of strings which are separated from this language notation. And another one is equal number of zeros and ones. So our language itself can be considered as a language itself, means programming language, C programming language, which contains a set of possible set of sequence of characters, individual strings L equal to all characters which are ASCII characters are to be considered. That is also one language. Another language example of language is equal number of zeros and ones. So previous one we have seen n number of zeros and number of ones is the equal number of zeros and ones. That means if n equal to 1 we have taken 0 case n equal to 1. That means n is here, if you put 2 here also 2. So 2 zeros, 2 ones, 3 zeros, 3 ones. So equal number, that means suppose for example double 1 we have written, and zeros also you have to write 0 0. Maybe in any order. The three zeros, for example, 3 zeros. 1 also you have to write 3 ones. Like that, equal number of zeros. Such type of strings are to be formed in this given language. That is here also in the example 0 1. Here 1 0 1 1. Here also 1 0 1 1. 2 zeros 2 1. Here also 2 zeros 2 ones. 2 zeros 2 ones. 3 zeros 3 ones here. 3 zeros 3 ones. Like that, we can describe several. We are going to get many number of strings which are formed from the given alphabet 0, 1, so that this language is considered as an infinite language, and the characters are also to be recognized. Sometimes in case of C programming language, where C or Java, we are going to use a keyword notation, like such as a class is a keyword, import is a keyword, public is keyword, static, like that, different types of keyword. That is also considered as one language notation. Why? Because it is a one string. It is class, individual characters combining sequence of characters. It is one string. Import is one string. Public is one string. So the combination of string 1, string 2, all these things you can define inside one language. But what is the defined sigma here? Sigma may be characters a comma b comma small b. Like that we are going to define this, etc. So in this denote the alphabet and getting the language L. And also to Java tokens, white spaces. These are also considered as examples of their language notation. So here simply a language means set of strings to be formed over an alphabet sigma. Empty language. What is meant by an empty language? Here empty, the language which contains at least one string, but empty language does not contain even empty string also. So that is called as, we are here, what is the difference between epsilon and phi? So here epsilon is nothing but null string. Epsilon is nothing but null string, whereas phi, even null string also not allowed here. Here null string also not available. Where here epsilon means null string. That means it is an empty string. Epsilon is called as an empty string. That means here the string is available, but that string is called as empty string. Where here in case of phi, this empty string also not available. But in case of null string, empty string may be. That's why this is not equivalent. Here, this is the phi is not equivalent. Generally, it is denoted by empty string. It is phi is denoted by empty set of strings. Empty set of strings. Whereas for epsilon, it contains one string that is called as empty string. That is the difference between phi and epsilon. So is it both are equivalent? No, both are not equivalent. Why? Because here epsilon contains one empty string, whereas phi does not contain empty string also. That means there will be no strings. There will be no strings. So in the language which is defined with an empty string epsilon, that is epsilon. It is empty string. Whereas another language is defined with some empty bracket. That in this case, if empty string is also not available. Empty string also not available. So this is counted as one string. How many number of strings are there in a language? Now here L is defined with the epsilon. One string is available, but here how many strings are available? There will be no strings in the language L. So that's why this epsilon is counted as one string. Here this empty is considered as no strings. So one string is not equivalent to no strings. Yes or no? So that's why here both are not equivalent. So whenever if you want to define a language which does not contain even empty string also, in that case you can define that one as a fi. Whereas you want to allow some string and not all strings, only the empty string, then in that case we are going to use a notation that is called as epsilon notation or lambda epsilon also, or another one is lambda. It depends on the notations which are using. So these are the two symbols, that is notation specifically applied for a given language, whether it contains empty string or any other listing of strings can be verified. And we are going to perform some operations on the strings also. For example, here what are the operations we can perform? That is, concatenation is one of the operations generally we can perform on strings. For example, if one string is to be considered AB is one string, that is U equal to AB, one string, another string BAB, then concatenation, that means U and V. So concatenation is generally denoted by the combining of the string 1 and string 2. So what is the string 1 here? String 1 is U and string 2 is V. And what are the contents of string 1? Here the contents of string 1 are AB. And what are the contents of string 2? BAB. So there will be no other operators are to be allowed in merging. So in the previous slide we discussed about the what are the operators that is not allowed. That means we cannot put comma or parenthesis like that. So that is called as a combining of the merging of the individual strings. So we can use this can be applied to the several number of the strings also. For example, if there is a string with X with some AB and another string Y contains some BC and Z contains CA. So the combination of these strings, three strings also can be represented as XYZ equal to AB followed by BC followed by CA. So here it is a simple notation to represent a concatenation of the result for the three strings. Four strings or five strings, any number of strings. That means we can apply this one to the at least two strings minimum. Whereas one string we cannot append to any other one. So that's why it contains at least two. We are also find out the prefix of the corresponding string and suffix. We are aware of what are the prefix and what are the suffix of a particular string. So for example, here 101, if you consider some of the strings that is to be formed over this V, that is to be as 1. What is the 1 here? What are the characters that is to be available previous to the string? That means before the string. That means first character 1 or another first two characters 10 and 3 characters. Those are called as prefixes. And we can also add epsilon, empty string. Why? Because epsilon is an empty string which is to be defined over an alphabet, but this is also to be considered as a prefix or and the suffix notation. If you append with epsilon with 101, we are getting the 101, whereas epsilon with 101. For example, here in case of suffix notations, 101. So here you can consider 1 and suffix 01 and another suffix is 10 and epsilon. So for the three cases we are going to include epsilon. That means epsilon is to be append with 101, we are getting the same string. Here also epsilon with 10 we are getting the same string. So in that way we can easily identify what are the strings that is to be formed for the given string with the suffix values and what are the strings that is to be formed with the prefix values. And sometimes we are going to find out these substrings which are available in the given string. So if the given string is some contains some, for example, 101. then that string, the strings that is to be formed from the given string. So we can identify 0 is one substring, 1 is one substring, 0, 1, 1, 0, 1, 0, 1 itself is a substring. Why? Because if you take epsilon 1, 0, 1, then that is also a substring. So that's why epsilon is a substring part of this one's individual strings, and all the prefixes and suffixes, that is also a substrings for the special cases considered. And proper prefix and proper suffixes is to be considered, recognized as what are the, suppose for example, if the suffix or proper prefix, U is a proper prefix and V is proper suffix, then prefix of U and prefix of V, that means suffix U, which is not equal to V. What are the prefix? Previously we calculated 101 prefixes, epsilon 10. So epsilon 1, 10, 101. So out of this we are going to eliminate, exclude the given string, or exclude the given string. Remaining all considered as proper prefixes. Remaining all considered as proper, except the given string. The string, all the strings includes all the strings except the given string. So here also, what are the epsilon? What are the suffixes? 1 is one suffix, 0, 1 is one suffix, and 101 is one suffix. So out of these strings, which one is given string? Which one is there in the given string? Given string 1. So this is to be excluded. So remaining are considered as a proper suffixes. So what is the difference between prefix and proper prefix, suffix and proper suffixes? So both are same. That means both are same means what are the strings that are to be considered? All the strings are considered, that is prefix of this one. All the strings are to be allowed in the suffix of string except the given string. So we are going to list it out all the prefix values. This is one prefix for 101, epsilon is one prefix, 1 is one prefix value, 101, 10 is another prefix, 101 is also another prefix. So out of that prefixes, a proper prefix is to be obtained by eliminating, excluding given string. So what is the given? Epsilon is not given string, 1 is not given string, 10 is not given string, but 101 is the given string, actual string, given string. So that is to be eliminated and we are getting. Similarly, a proper suffix, epsilon is one proper suffix value, 1 is one suffix, 01 is suffix value, whereas 101, that is also suffix. But when it comes under proper suffix, we are going to exclude the given string. What is the given string? 101. So we are going to exclude them. That is called as proper suffix. So prefix notation, suffix notation, and proper prefix, and getting these values from the given alphabet, that is given set, that is either 0, 1, or depends on the character symbols which are to be available over the alphabet. Another operation we can perform, that is string operations. So that is called as power operation, power of a string. So generally we can define a string with the individual set of sequence of characters, X, Y, or A, B, C. So that is the notation to represent. So any string that is to be formed with the help of the certain characters, sequence of characters formed a string. So generally, how can you calculate this power of the string? So we are going to represent this power of notation, power string, as a concatenation copies of the values of corresponding are given X. For example, we are going to denote X equal to some 0, 1, 1. Then we are going to calculate the power X power 0. So the power values of the given string. The power values of the given string. That means X power 0, X power 1, like that. So here there will be no other characters to be defined in this one. So X power 0 is to be considered as alone as epsilon, whereas X power 1 denotes the symbols which are available in the given string, that is 0, 1, 1. So we are going to write 0, 1, 1. Whereas X power 2 is to be defined with the concatenation of X and with X. So what is the X value here? 0, 1, 1. and another one is 0, 1, 1. So this is to be defined 1x value, this to be defined with 1x value. So this 2 comes, this one, it is to be recognized as x power 2, and that is to be written as x 0, 1, 1, 0, 1. So in this way we are getting the result. Whereas x power 3, that is to be denoted as x power 3 as x concatenation of another x, concatenation of another x, concatenation of another x. So here, first x value defined is 0, 1, 1, and the second x value is to be defined with 0, 1, 1, and the third x value to be defined with 0, 1, 1. So the string to be, which is same as the, so x power 4 also can be defined in the same way, x followed by x followed by x followed by x. So 0, 1, 1 followed by 0, 1, 1, 0, 1, 1 followed by 0, 1, 1. So like that, x power 5, x power 6, 1, x power 8. The powers of the corresponding string. So here in this example, string is considered as value x. So that may be 101 or 010 or ABC, any other formation of the sequence of characters, that is symbols to be available in this string. But the powers to be, but the power of the string can be calculated as concatenation of the given string. Concatenation, that means the concatenation of the number of strings that is to be available. So for example, x power 2 concatenation is x into x, x power 3 x, x, x. So that, like that we are going to use this power of strings as one of the mechanism, sequential representation of the concatenation of the individual copies of the strings, sequence of individual combination of this representation is called as concatenation of the string copies of x. So x power 2 that is to be defined, and x power 3 that is to be defined, x power 4 that is to be defined with this one, x power 5 that is to be defined like this, so on. So this is the notation to calculate or define the powers of a string with the help of the given alphabet, either 0, 1 or sequence of symbols a comma b, lowercase letters. So depends on the string or language, the individual copies are to be varied from one to another, so that remaining other strings are also to be developed. So this is an example of notation to represent the power of a string. So here we consider as a string as x value, and individual copies of x value to be generated. Later we are going to combine to produce the resultant copies of x with the power notation. And for example, in the alphabet notation also we can represent power of alphabet. Here string we consider x value, previous value. Now here in this one we consider as alphabet also. So here, for example, sigma, we know that in the previous discussion, sigma may be denoted with individual either 0, 1 or a comma b. So 0 is one symbol, 1 is another symbol. So based on these symbols we are going to generate a language. Sometimes we are going to produce an alphabet with the powers also. So what is meant by powers means, here the same we are going to apply sigma power 0, set of strings to be formed with the corresponding length of the symbols. That means here what is the epsilon, which contains an empty string. That is the first string that is to be available. Whereas sigma power 1, that means the number of symbols that is to be appeared. That means 0, 1. One total copies how much? 0, 1. So sigma power. Whereas sigma power 2, we consider that is sigma, and that is another sigma. Concatenation of individual. It is one alphabet sigma, another alphabet sigma. So it is used to denote a set of strings. So sigma contains set of strings. Another sigma is to be considered, and that is also defined. So that 0, 1. Here what is sigma? 0, 1. Here also sigma is 0, 1. So we are going to use a concatenation mechanism for the defining of this power of alphabet, which is nothing but sigma power 2. But what is the result here? So we are going to apply a concatenation mechanism, that is 0 with 0 and 0 with 1. Another 1 with 0 and 1 with 1. So what we are getting? 0 with 0, 0, 0, 0 with 1 we are getting 0, 1, and 1 with 0 we are getting 1, 0, and 1 with 1 we are getting 1, 1. So this is called as sigma power 2, which is equal to sigma power. Similarly, power of 3 alphabet, that is power of alphabet 3, 4, 5, like that. So power of 3 means sigma followed by concatenation of another sigma followed by another concatenation of. So what is sigma here? Given sigma is 0, 1. Another one is 0, 1. Another one is 0, 1. Now we already calculated some 0, 1 with some notation. 0, 0, 1. That is sigma followed by sigma, sigma. Sigma, sigma, already we got some result. So either previous two sigmas are beginning or end of sigmas. So we are going to write 0, 0, 0, 1, 1, 0, 1, 1. So this again contains 0, 1. So these two consider as sigma, sigma. This consider as sigma. So what is the result? We are getting 3 sigmas. So that is same as. So here in this one, we are going to get sigma concatenation with 0, 0, sigma, and this 0, 0 concatenation with 0, 0, 1, 0 concatenation with 0, 1, 0, 0 concatenation with 1, 1. For example, here 1, if you consider 1, 0, 0, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1. So in this case, we are getting 0, 0, 0, comma 0, 0, 1, 0, 1, 0, 0, 1, 1. That is 1. And with one combination, we are getting 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So what is the resultant here? Sigma power 3 is equal to, this is the string, 3 zeros, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 3, 1. So we are also calculated sigma power 4. This is called as power of alphabet. Since alphabet is denoted by sigma, we can calculate any number of powers of the particular sigma. But what the thing is, we have to verify what is given value sigma. Here, sigma power is denoted by sigma, followed by sigma, followed by sigma, followed by sigma. So we already know the 3 sigmas previous calculated. Individual sigmas previously 2 sigmas and 3 sigmas, that is sigma power 2. 2 sigmas means sigma power 2, 3 sigmas means sigma power 3. So previously we have denoted already sigma power 3, that is 0 with notation 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 3, 1. And again the combination of with one more sigma 0, 1, we are getting sigma power 4. This is all sigma power 3 and this is sigma. This is one more. So sigma power 3 followed by sigma power 3 into sigma. We are getting one more result. So sigma is 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, etc. So we are getting sigma power 5 also we can calculate sigma power 4 to sigma. Like that, all powers of an alphabet can be easily identified with the help of concatenation of the corresponding string values with the defined alphabet over sigma. So here what is the sigma is defined? 0, 1. Suppose if the alphabet is changed, then the result of the particular values or strings are to be changed based on that one. So here chosen alphabet is 0, 1 only. So based on that, the language strings are to be generated. For example, here if the alphabet is given a comma b, sigma is given a comma b, then sigma power 1 is to be considered as a comma b only, and sigma power 0 is epsilon only, whereas sigma power 2 if you consider sigma into sigma, that is equal to a comma b and a comma b. So a with a with b, B with A, B with B. So A, AB, BA, BB. This is the defining the sigma power 2. And sigma power 3 is equal to sigma power 2 into sigma. So here the with AB with this one. So like this, the value of the powers of alphabet are to be varied from one language to another language based on the given alphabet. So in this example, we consider the binary alphabet. So that's why it is to be represented with the notations as 0, 1, 1, 1, 0 like that. So any alphabet with the string over the defined sigma and absolute value, the length of the strings to be calculated, and this is called as powers of string, sigma power k. So where k is an integer value, that means k equal to 0, k equal to 1 or 2, 3, k equal to 0, comma 1, comma 2, like that's one. Here it denotes the set of strings that is to be denoted. Powers of alphabet that is to be calculated previously, that is 0 epsilon value, sigma power 1, sigma power 2 is sigma followed by sigma, sigma power 3 sigma square dot sigma, sigma power 4 sigma power 3 dot sigma, like that sigma power k, where k equal to 0, comma 1, comma 2. All the powers that is to be denoted here, it is called as sigma power star. The star is to be used to represent 0 or star. It is to be used to represent 0 or more number of occurrences. 0 or more number of occurrences. That means how many number of times the sigma is to be appeared based on the value of k. So here that is to be simply denoted as star. That means the sigma may appear either 0 time, 1 time, 2 times, 3 times, 4 times, 1, n times or k times. So this number of times may appear. So any number of times that is to be prescribed with a notation that is called as sigma star. So all the powers of an alphabet can be simply described with a notation that is sigma star. Here sigma is nothing but an alphabet, and what are the symbols that is to be available in the alphabet is 0 and 1. Sometimes that is a binary alphabet, and in the previous case we have also seen A, comma B. And sigma power 1, the set of strings, and either the number of strings is the consider with the how many number of strings are available, all the strings with the length 1. So we have to example in the case of 0, comma 1, the binary alphabet that is sigma equal to 0, 1. We are going to see sigma power 1, this one. Sigma power 2, sigma power 2 dot sigma. So here 0, 1, 0, comma 1, sigma power 0, comma 1 with 0, 0, 0, 1, 1, 0, 1, 1. So here the individual strings 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. The main important thing is the number of strings that is formed over the length sigma, that is 1. So the individual length of string also 1. Whereas in sigma power 2, the individual sigma power 2 means sigma part sigma, that is 0, 1 followed by 0, 1. We are getting 0, 0, 0, 1, 1, 0, 1, 1. But here the length that is to be defined for all the strings. Here what is the string length? 2. Here also string length 2. Here also string length 2. String length 2. Here what is the power that is to be defined? Power 2. All of the strings with length 2 only. Whereas here sigma power 3, if we consider what is the length of string here 3. Here also 3. Length of string is 3. So previously we have defined how to calculate the length of the string. So absolute W, which is available, the number of individual sequence of the characters. A is one character, B is one character, C is one character. So mod of this one is 3. So in the same way, here also the number of characters that is to symbol that is 0 is 1, another 0 is 1. So we are going to consider this one as string length 2. Here also string length 2, here also string. Whereas here string length is 3, string length 3, string length 3, and string length. So if string length is 3, that means that depends on the power alphabet. So here sigma power 4, that means all the strings, all strings with length 4. That means only the strings that is to be allowed with the length 4. All the strings with length 3. all the strings with length 2, all the strings with length 1, all the strings with length 0. So the power of alphabet indirectly it is denoting that each one with the length of the string. That means sigma power 1 set of all strings with the length 1, set of all strings with the length k. Sigma power k denotes all the string lengths allowed with the length of string is k. So in that way we are going to define the power of alphabet also, which defines the length of strings that is to be allowed inside this one. So length of string, all string length 2 with sigma power 2, all string length 3 with sigma power 3, all string length 4 sigma power 4, so on up to string length k denotes where k denotes the number integer value, that is k 0, 1, 2, 3, 4. If length is k, then k number of that is strings are to be allowed in that particular language. So one can decide based on that. So there is a difference between star operation and sigma star and sigma plus. So here sigma star denotes the length of string which include epsilon followed by remaining all symbols, whereas sigma plus which does not contain epsilons. So that is the difference between sigma star and epsilon. That means contain all number of strings, which contains all number of strings. That means epsilon, A, double A, triple A, all. And here also epsilon, A. But here we know that sigma star, that is an infinite. That means infinite in the sense the strings are to be continuously processed. And some of them are finite. The length of the string is finite in that one only, but the language is to be continuously. We already discussed about F5 value, which does not contain empty string also. And the sigma plus is nothing but it contains all the strings except epsilon. But whereas here in the sigma star, it includes epsilon also. Whereas in this one, in the plus, it does not include epsilon. That means empty string is not included. For example, if you take A comma B, in this one, all the strings, set of strings are allowed, star. Whereas in the plus, except epsilon, remaining all are same. So A is B, double A, A, B, B, A, double B, triple A, double A, B, A, B, A, A, B, 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 A, except epsilon. Remaining all strings are to be allowed. So the only difference between sigma star and plus is that epsilon is to be included in star operation. So here in the star, it denotes, star defines that 0 or more occurrences, whereas plus defines that 1 or more occurrences. So here 1 or more occurrences starts with sigma power 1 only, whereas here 0 occurrence sigma power 0, where sigma power 0 is epsilon, where here it is not included, minus epsilon. So that is the only difference between star and plus operation with the power of alphabet notation. And we can perform some of the operations also, union, intersection and difference operation also. Here we already know union means combination of with another first element with the second element we are going to combine. Intersection means the common elements which are available from set 1 with this language and in this language. Suppose this is the language we described one and this is another language. This language contains some set of strings. This language contains some set of strings. Out of these strings, which one is common in both the languages? Suppose AB is the one string which is common with both the languages. So we are going to find out that one. A is not common, remaining case is not. So for example, we are going to separate, difference, finding out from this language. That means what are the strings that are available in this language which are not available in this language. So that is to be removed. So here AB is one language which is available, already available, so we are going to eliminate. BB is not available, so we can keep as it is. So only removal is required from this language. One is A comma triple A. BB is removed and A comma. So in this way, we are going to perform the operations union, intersection and difference with across the language which contains set of strings also. And we already know L star and star, L plus, that means a complement operation also we can find out by using a power notation, that is sigma star minus L. That means what is sigma star? We know that it contains 0 or more occurrences of particular alphabet, and we are going to exclude the given set, given language. So a given set means A is available, B. We are going to eliminate these two things and remaining all strings that is to be considered as L bar, that is complement operation. Sometimes we are going to recognize the reverse of a language, given language. So how can you write a reverse of the language? For example, here the language is given as which contains strings A, B, W, A, B. Simply you are going to write the reverse of A, B, you are generating B, A. And reverse of AAB, we are getting BA. And reverse of BAB, we are getting the reverse of, that is ABAB. And for example, if you are writing A power n, B power n, reverse of a language can be generated as B power n and A power n. Previously, we described the concatenation of the two languages also. That means L1 is one language which contains some strings. L2 is another language which contains some strings. Then the concatenation can be applied A with B and A with A, AB with B, AB with A, BA with B, and BA with B. So we are going to get this type of. So A with B, A with A. So AB triple A. We are getting the result of this two. Whereas this second one, BAB with BA and this one. So we are getting AB and AB double A. So this is the result which is getting for these two cases. Whereas the third one, BA with the B and then BA, we are getting this one. So BAB, BA with B and BA with W. So concatenation is only the string appending with the another language. So here also we can apply with, previously we applied with strings, now we applied with the languages. We know that star operation and plus operation. This star is also called as clean star, but here we applied across the languages. Previously we applied with the alphabet, so sigma power 0. Now we can apply with the language also, L star L power 0. That means the language contains set of strings. So number of strings that is to be appeared in this one is depends based on the power of a language. That is here L power 1, that is number of strings 1, here number of strings 0. Like that, the given language which contain depends on the string. Sometimes the string may be repeated also in this one language. For example, A comma BB, that is, we already know that it contains 0 or more occurrences. So epsilon is a 0 occurrence, and this is one occurrence, and this is 2 occurrences, and this is so. That is L. This if you consider L star, then L power 0, L power 1, L power 2, L power 3. So L power 0 is epsilon, L power means 1 into 12, L power 2 means L dot L, that means concatenation of A, B, B, followed by A comma B, B. So A double A, A double B. So we are getting this set. Then concatenation of B and this one, we get B, B, A, 4 B's. So in this way, we are going to perform the concatenation with the language also with L power 0, L power 1, L power 2, L power 3. And this is another example which is described 0, 1, 1, 1, 0. Same star defines the number of times to be repeated, 0 and 1, such that we are getting several number of pairs of strings. And L plus. So here plus we does not include epsilon. Epsilon is not available. Remaining all strings we are getting. So that means L power 1, L power 2, L power 3. Only except epsilon. That means L star minus epsilon. So here it is considered epsilon is lambda also. Another way represent. Remaining all strings. That means here L star denotes L power 0, L power 1, L power 2, all minus epsilon. That means that this epsilon and this epsilon, we are getting the strings L power 1 swarm. So in this way, we are going to, so previously we have calculated L power 2, L dot L, and the length of strings with string length 2, string length 3. This is string length 2, string length language with L dot L, L square, L power 3, L square dot L, L power 3, L square dot L, L power 4, L power 3 dot L. Like that, so we are going to determine the corresponding results. So finite automata, which is to be represented with the cases, that is alphabet, strings, grammars, and we are going to discuss this finite automata concept with the regular expressions and languages in the next coming session. So all the things which are to be defined are described in the given textbook, that is compiler specific techniques, that is Alfred Sethi Ullman. So you can find the contents from this. So as for today's session, we are closing the thank you all of you once again. We'll meet with the next topic, that is regular expressions, in the next coming session. Okay, thank you all of you. With this, thank you.
Like, share and subscribe. Hit the bell icon for more updates.